Welcome to a new test and teardown video. This time it's another medical device from Stryker called X8000 light source. And this one, the output is for light cables, and I just happen to have a product that uses a light cable. So I hope I can get this one to work. I never owned one of those light sources, so I'm a little bit excited. As you can see in here, let's see if I can get a little bit of light like that. See, it is completely closed. Of course, you don't want this high power beam directly into your face. So the idea is you open here and then it opens like that, and then click, it goes like this. And then when you click in the light source, let me show, let's try to do it with this one. So you click in here and push, click, and then it locks, and then the light cable is now locked into position. There are many different types of light cables. Some fill up this entire hole and they kind of mate more nicely with this. My cable looks a little bit different. Let's try and see if my cable will have any kind of success with this one. So this is for my product, but it goes all the way in, see? And when I push it here, I think I hit some optical stuff in there, so I don't hit this, see, this ring. So that means I don't think this will work. This ring here should have been out there or something. But what I can do is I can maybe hold it like this and then push, click, and then leave it like that. Then I should probably get all my light output anyway. And if I push this part in, the detector in there should still see there's a cable, and then I should be able to connect to my unit using the other end and then get all the light out this little hole here. I think it's super fascinating to think about. You have a super flexible, lightweight cable and you get 450 watts of light through this cable, and nothing gets warm or anything. It's very fascinating. I think they used it for all sorts of surgery things. And I don't know, I think they still use this kind of technology today, but maybe the light source is, of course, LEDs and all that kind of stuff. I believe this one is a lamp of some sort. So let's try and open and see what is inside such a thing. It is very big for just a little lamp. So here at the back, we can see a little bit more information about Stryker, the company. It's located in California. And here's the Europe office. There's a funny USB connector. I don't understand exactly what that is. And then 3 really weird connectors as well. Looking a little bit like a fire wire, some sort of cable like that. 2 fans. At the right side of the unit, there's a little door we can open here. And then we can access all sorts of... What the heck is that? So there's a little stepper motor with a funny pattern. Oh, this is like an... Look what that is! This is brightness control. How nice! So this is how it's done. Oh, really? Maybe this... Oh, that is sexy. You just pull out the handle like that and then... What the... That is the That is a lamp. Whoa, an impressive cooler. And oh, there's a little Dallas chip here with some secret information about the lamp. How about that? That I've never seen before. And this is how you connect to that one. And there's a little temperature sensor down there. Oh, this probably sensors on the output air and all that. I really want to open this this unit. This looks absolutely fantastic. And what have we got here? Two little red components. Yeah, okay, now I know what they are doing. So that is a little read sensor. See, here's the door. And of course, that is a sensor for the door. And the other sensor is for this module. So when I plug this, let's try and see. It's probably locked. Click. No. That's just double door sensor. It is, as always, a lot more complicated than first anticipated. It is also extremely beautiful, well designed. And that is a classic thing with medical. See, there's a temperature sensor. Some sort of a relay, I guess this is temperature activated relay or something like that. Brightness control. I really love that idea. See, there's a little micro switch, so it knows where it is. And then I think this is a glass light guide, that one down here, so it can handle all that temperature, and it's also cooled with a lot of aluminium. And I think there will be a some sort of a sensor on the main board or the display board here behind this plastic, because I think the unit will not be able to turn on the light source if there is no cable plugged in. And I look forward to figure out how that is detected, but I need to open into the display board as well, right? The main switch is extra isolated, and this is again classic with medical instruments. There's a high degree of double isolation, and also mains cables. They cannot just go inside the cabinet to the mains entry. They need to be double isolated. There's a little lamp inside the switch, and it's made really cute, see? Like that. So the LED is in there, and then the cables go back. That is weird. And the cables nearly touches the sharp metal. If I touch this, it feels really, really sharp. So that is, of course, low voltage, but still, I'm not super proud of that. You can even see, yes, you can see scratch marks on the right, on the red one here. See? Mains entry filter, and there's some sort of a ballast thing. I think the way that this works is, in case the lamp blows up, you need to have some sort of an active xenon diode or something like that that connects to the light bulb or whatever. I don't understand exactly why that is necessary, but I've seen something like this in xenon drives and stuff like that, so that's probably why. But I don't call myself a xenon lamp expert or anything like that. The xenon lamp is only 2 wires, and you need a very high voltage to start this. So there's a trigger system that triggers a very high voltage charged in some capacitors, and this hammers into this inductor that is in series with the bulb, and this strikes a starting pulse or starting spark inside the bulb, and then it goes like very low voltage but high current. And then there's another power supply, I think probably this and this down here, that will drive the lamp. And there's a 6 amp 12 volt power supply here as well, probably just to drive all the digital. And then there's another board hidden down here, full of all sorts of electronics as well. So that's the blue one. What is that doing there? And then a very big microcontroller board with all sorts of power supplies, microcontroller Hitachi something, some RAM, and another controller for some external interfaces, and that is probably for the camera interfaces, because this is used for surgery with cameras, and they control the light source and all that kind of stuff using a very fancy smancy digital interface. So that is probably all this stuff to remote control, yeah, your light source. But this one is made in China by an external company, and then they put on the California name and number here. Well, that's a little bit funny. So it's probably designed there and then just manufactured in China using different fonts. Well. But it's nice and clean and all that. So I think I should probably just try and power it up and see, is there any light? So it clicks out the brightness control all the way to negative, and then it boots up, and it's using 24 watts, and it is now in standby. Oh, look at that, it's talking Danish. We even see how many hours of the lamp, and it's supposed to run about 500 hours. I went to their webpage and found some information. The 450 watts I talked about earlier in the video, that is written on the back side of this unit. The lamp is a 300 watts xenon bulb. So you should be able to just hit the run. And then there's no information or indication about whatever, right? So maybe it has something to do with this. So I click this in. Now there's probably another sensor here. No luck. Let's try and power it up again with this. Well, let's just stick something in. And then click. Okay. What else can we do? And then we try. I did put a magnet here on the sensor side, so I guess the door should be closed. So now I should be able to. That is annoying, and this is of course how it is. When I get stuff, there's always defect. Darn it. Here we go. Now it just turns on. When I turned on the unit, it just turned on. I mean, isn't that amazing? And then I hit run. And then I get output right here. And then I can turn on and off my output. I really like this motor drive. It's using 300 watts, 10%. I can't do any less than that. How long is it going to take before it melts this? I don't know. What happens if I turn... Oh yeah, you see? Okay, so it turns... So there is a detector of some sort in there. Oi, oi, oi. So I melted this plastic. That's probably not such a smart idea. So I will turn it off again. But during... according to what I was able to see online, this is not how it works. You should always push the button and then it will turn on the light source. This is not what happened here. I had something in here and then it just went immediately on. Really weird. I think I figured this out. There isn't any kind of electrical or mechanical switches or anything like that. There's just this. This is the lock. Cling. And this is released by either pressing in here, of course, or like what I did here. So this one is connected using some mechanical thingies. When you press this part and it moves in and all that. And then you can release it like that and then freely this one will move in. And then cling, hold your thing. And so that is what I did. And this created the light, right? So let's look why this happened. Inside this thing is the display driver board and the little switches and whatnot. A little microcontroller is doing that. Fantastic. But that one is a little detector and it sends out a light beam and then it reflects the light beam to the detector. So that means you need to have your output mounted. What I did, I put in this one so it reflected the signal and then it thought, hey, you got something mounted, it's probably fine. I could also stick in my finger and then I will burn my finger. See, how smart is that? So that is exactly how it works. So next time you come to one of these and it's open like this, just stick in your finger and hit on. But don't push this one in with your finger. You're gonna get hurt. This one, I mean, this gonna hurt your finger. Okay, so don't do that. But since my detector is thinner, and I don't think I don't want to modify this one for my unit, right? But maybe I can just remove this holder thing, and this way I can just open it and then carefully close it. And then there is no this clickety clackety schmackety smash my things. I don't want to have any of that, by the way. So I think I'll modify this a little bit and I'll probably remove this one as well. I rather want bright, shiny light out my face. This way I know, ooh, it's dangerous. It's hot. I'm not going to stick in anything. Much better solution for my use. So that will be my modifications. So the little mechanical mods here. This keeps this holder thingy in all the way in. This means I can easier stick my type of optical cable in. Here's a little magnet just for now. I still haven't really understood why they got two sensors in series. Is that really necessary? And here is my other little sensor mod. It's just pointing to that piece of plastic. I hope this will activate it. Otherwise, I have to pull it all apart again. Yeah, and then I remove this annoying hold lever. See, now it is that easy. Much better way. So I feel we should try this again. Let's turn on mains. And then see what happens. I really hope that it will only turn on the lamp. Ugh, damn it. It turned on the lamp immediately. This is a little bit annoying because it says standby here. So there is some sort of a problem. But I have the output here. And then it is not responding. So, and then you turn it on. Aha, so there is definitely a on-off sort of problem. Wow, this is bright stuff. All the way. %, that's pretty cool. So let's try and put in my little device here. This one should definitely be able to handle the temperature. So I can open here, stick it in, and then I'm done. And now I have all my power here. And this is only 20%. So let's crank it up. Oi, oi, oi. This is some... Oh, you can definitely feel the heat here immediately. Oh, you need to move it like that. So there's so much power here. So I can really use this for all sorts of cool things. I'm super happy about this, but there's definitely another problem with this unit. So it just turns the lamp on. So yeah, I left it on. Okay, now I'm gonna put it into standby. See, the lamp is still on. So it's not supposed to do that. It's supposed to turn on and off that lamp. And I don't have any schematics or nothing like that, so there's probably a relay or some kind of stuff between the control circuits or the lamp on off thingies that's not working. I don't really want to start messing around with this. Also, I mean, this unit is it really got 100 ways to unalive you, really. It's not like I'm super afraid of it, but I really respect stuff like this with all this high voltage and the way that the whole way that it works just scares me a little bit, and I need to poke around with how it's controlled, and I don't know, I don't want to do that. I just want to be happy and alive. But as long as it's giving light, I mean, I feel like I'm done for now. So until next time, I want to say thank you very much for watching. I hope you had a little bit of fun. See you. Bye.